So in this quick video, I'm going to show you a way to find the transmitter frequency using FieldFox. Let's say you have a transmitter that you found somewhere that you couldn't identify who left it there, and you just want to see what is the transmitting frequency and also the power that it's using. So for example, this is the sensor at the door. So wherever we have latch on and latch off, the signal will be transmitted, as you can see that red dot there. So let's go back to FieldFox, and this is how it looks like. So when you're first using the FieldFox app on Android, this is a welcoming page. So you can go to intro, the video and demo video, whatever you need to do. If you want to connect directly to the instrument, this is where you're going to press instrument, and this is going to connect. And I have this FieldFox 100.24 connected previously, so I just connect. So this is how it looks like here. So the next thing I want to do is I want to limit the frequency span. So I just preset the FieldFox just to start from scratch. So you're going to see how you're going to find the transmitting frequency for an unknown device. So let's set the start and stop frequency. So we know that most of the transmitter that you use in the household for IoT is either in an ISM band or a special band. So for ISM band, we can start with 433, which is being used mostly for like garage key, even your car. That's a good region to start. Then stop. I don't think this sensor is using the 2.4 gig ISM band or even 5.8 gig. So let's click the stop to 1 gigahertz. So we start from 0 hertz to 1 gigahertz, which is alright to start with. And we know that because this is over-the-air measurements, so there are some attenuations from the transmitter to the receiver on the FieldFox. This is where I put the FieldFox is on the floor because I run out of hands to carry it. We have an antenna attached to it, so I'm going to turn on the preamp, and let's say we set the attenuator to 20 dB just in case the transmitter power is way too high. Then we go to the next thing I want to do. I'm going to put a trace max hole. When I trigger the sensor, I want to know where is the frequency. So this is one of the best way. So I'm going to close the door right now. So you see the spike here, somewhere here. Then we turn on the marker normal, and then we want it to be on trace 2. So we go back to marker, peak. So that's what we want to zoom in. So the next thing I want to do is, let's go to marker tools, marker center, and let's try it. Yep, that's about it, the 433 region. So we know that the sensor works around that area. So let's zoom in. So currently it's 1 gigahertz bandwidth. Let's lessen it down to, let's say 10 megahertz. Well, let's start with 20 megahertz for now. I can change the resolution bandwidth just to make it look much better, and I'm going to trigger the sensor again. So as you can see, like it happens just there. Let's go to marker center, marker, pick, and then we move it to the center. So it's about 43.9 megahertz. Let's try again whether it's right. So it's roughly there. So let's lower down the frequency span to 5 megahertz, and we trigger the sensor again. There we go. So if you want to zoom in furthermore for a more accurate transmitter frequency, this is one of the ways to do it. To summarize, first of all, we have to know what type of transmitter that you are dealing with. If it's an IoT, most likely it will happen at the ISM band of the country. Then secondly, we want to zoom into the ISM band of interest, then slowly zoom in, and before that, do remember to turn on the max hole trace so that you can see the activities being recorded is there, and then you can zoom in further using the marker and the marker to center. So with that, step by step, hopefully it will help you. Thanks for watching.